Welcome back to the most boring Houdini series that you will find online. I know, but we are Cinema4D people and we need to ease very smoothly into Houdini, otherwise we'll be scared, as I was for many years. And I opened it and I was closing it after 15-20 minutes. The best record I've done in Houdini, I think, would be like something 3-4 days or something, and then I'd be like, okay, fuck it. I'm just going back to Cinema4D to throw some MoGraph in there. And yes, you'll probably get away with many things with MoGraph, but you will gonna miss things in Houdini like Vellum, which is really my next subject of exploration, because Cinema4D doesn't have a consistent cloth system or soft bodies or hair or all that things. Anyways, that's for another time, for the fun part. Right now you're in the boring areas, in the dark side of Houdini, and we're gonna look into a better depth the concept of attributes. So attributes are data that are flowing through geometry in Houdini. Data that flows through points, through primitives, and through vertices. In Cinema4D, objects have attributes that we don't see them. We don't take this into account, right? For example, this cube here has a certain position in space, so if we see its coordinates, right, it's on 0 or x, on y is on 100, and on 0 and z 0. So these three coordinates that define the position of our cube are called a vector. So what is this? What I'm looking here is what I would describe in Houdini as vector attribute. So whatever has 3 dimensions is a vector attribute. And what else has 3 dimensions? And besides position, normals have 3 directions, because wherever a normal is pointing, you see a normal is pointing here, so it's normal y is 1 and x and z is 0, but if a normal is pointing like this, normal is has a value on x as well, and if it's pointing a little bit like this, has 3-dimension direction. So positions are vector attributes, normals are vector attributes, UVs are also vector attributes, because although UV we draw on a 2D space, there are 3 coordinates there: the U, the V, and the W. And the W, I think, describes how the texture is applied on the surface. It's a little bit more weird concept, not straightforward as position and normals, but just letting you know that it's there. What else is a vector attribute? Velocity is a vector attribute, because when we define the velocity of an object, if it will go up or right, yeah, already up and right are 2 dimensions, but we can also define a velocity in Z, therefore 3-dimensional a vector attribute. And in Cinema4D, this coordinates is not referring actually to the position attribute in the same way as Houdini does. This refers to the pivot position in space. So if I make this editable though, and go to the structure manager, to points, for each point, I have this 3-dimensional component. So for example, I have selected this point 1. If I move it in Z, you will see it updates its position in Z, its position in Y, and in X. So now this is the position attribute for point 1, and it's a vector attribute. Same is with polygons, although I don't see X, Y, Z here in my polygons. Maybe there are some settings in Cinema4D, but Cinema4D is not so descriptive. Here it usually shows, for example, the connection of our polygons, that polygon number 4 is connected to vertices 1, 7, 5, and 3. This is what I suppose these numbers mean. Anyways, normals that I don't, while I have normals already in my object, if I go and define here via a normal tag, now in the structure, it also shows where my normals are facing in a weird way that, again, I'm not very technical to understand this, but again, normals have these 3 components. So vector attributes are 3-dimensional 3-dimensional attributes that we use in Houdini. And is one of the most used type that we will see further down the line. Vectors and float attributes. These two types are the most common ones. So what else is here? We saw the normals. In Structure Manager, you can also visualize the UVs, which says something UVW things. Again, I can't read this diagram very well, but in Houdini, this information is laid out in a much nicer way. So jumping in Houdini to do the exact same thing, I'm gonna create a cube, right? And I'm gonna open here this ugly, scary thing, the geometry spreadsheet, but this is much more logical because in Cinema4D, by the way, I had to make my cube editable in order to see things, while in Houdini, there is no such thing as editable, besides being a primitive, which is called a polygon in this case, but anyways, a parametric object, let's say, besides being parametric, when in any type we can see the position of the points and stuff like this when points exist. So it's not like that I need to convert my cube to something. Even if I do things down the line, I still have access to its divisions, etc. I don't lose this information, but this is not a parametric object anymore. So this is another advantage of Houdini. So going back to 2 by 2 by 2, this is how I define my cube. And for every point that you see here, I know its coordinates as I have them in Cinema4D. So if I middle mouse click here, hold middle mouse click here, I can see this information, but let me pop it this way with this eye here. So the description on this is some geometry description, where my pivot is in space, what's my size, how many points, primitives, etc. But what I'm interested to explain here is this one point attribute. This is what it says. It's called P, and it's a 3 float attribute. So I know that I said vectors and floats are a different thing, but they're also a more generic concept. So a vector is a component of 3 things. A float is a component of 1 thing in terms of mathematics, and it's consisted of decimal numbers. So you would write a vector like something like xyz, while you would write a float value like 1.1, for example. So 1.1 is a float value. So why Houdini confuses us like this? Why it doesn't say vector? Well, I don't know, but all it says here is that this is a 3-dimensional thing. This 3 stands for 3, therefore a vector. And these 3 dimensions, each dimension is a float value. So as you see, for this point 0 here, 0.5 minus 0.5, these are float values. So while 3 components in our attribute, they consist of float values. So if I can change the size, you see, to even smaller numbers. So these are all float values, right? But the attribute is a vector attribute. I hope it does make sense and it's not confusing, because at first I was like, why is this 3 float? I know this is a vector, why is 3 float, etc. Keep in mind that Houdini has other types of attributes that have 4 dimensions. Let's not touch the subject at all, it burns. But for the major part and what we'll be using are vector attributes. So here I have a point attribute, a position attribute, and by default anything I create here, even if I add a single point, let's say I have a point, I press and create a point, nothing can exist in 3D without position attribute. So you see, everything by default have this 3-dimensional position attribute, therefore a vector. So besides this attribute, let's create what we have in Cinema4D. So let's go and throw a normal SOP, and the normal SOP, it creates normals, but I don't see them here, and this is because the normals by default are created on vertices. So in order to see that, here are my vertices, and there it is again. Normals are 3 float attribute. It's a vector attribute that consists of float values. So if I see my info here, I have a point one point attribute, the position, and one vertex attribute, the normal. I know this is a little bit too much, but you will be quickly used to just see this info and know what's going on. So if I take this normal now, I can set this to points, and therefore if I go again to the points, I have point attribute of normals and point attribute of position. And you will probably wonder, why do I need to do all these translations and transfers from attribute to points to primitives? Because each node will use different attributes to do different operations. So, or the same attribute, but in different class, let's say, in different, some nodes will work on primitives, some nodes will work on points. I hope it makes sense. So normals, and let's also go and do a quick unwrap. I don't care how the unwrap look, but when I'm here, you see that I see the unwrap taking place in the viewport, and I also don't see the unwrap here because the UV, which is also how the unwrap, how the UV attributes are called in Houdini, is stored also in vertices. So again, 3-vector float. If we see this info here, we keep adding attributes to our cube. So the normal attribute now is on points. The position is the first attribute that is generated by default, and the UV attribute is on vertices, right? As I was saying in the previous course, we won't deal with vertex attributes most of the times. I personally haven't dealt with vertices at all in my experiments. I only use point and primitive attributes, but I'm using both vector and float attributes very, very much. So because these are the most basic things you can use. So far, again, normals, unwrap, and what else did I have in C4D? Yeah, this is the same thing. This is my UV attribute, this is my normal attributes, etc. Only thing though is here I have a much more better representation of anything. What else is a vector attribute? Velocity is also a vector attribute, and let's do something else in order to demonstrate the velocity here. So let's quickly create a grid, and let's use some copy to points, which is equivalent to the cloner, let's say, in a way, in Cinema4D. And what I'm doing is I'm cloning those cloning those boxes on the, I'm not used to navigating with shortcuts in Houdini. I do many things here, sorry for that. Let's take it one by one, uniform scale of 0.5. Right, so what I'm having here is some cubes scattered on the points of this grid, right? And I'm gonna quickly go and use some bullet solver. So the bullet solver is how you define rigid bodies in Houdini. And if I press play, by default bullet has some embedded gravity here in its forces. I'm not gonna go through all the settings, of course. I just wanna show you that what the velocity attribute is. So if I go here and do an attribute create, because besides the nodes that have attributes in there, you can create your own attributes, you can create the known attributes, and one of the known attributes in Houdini is called V, that stands for velocity. And velocity, as I know, it's a vector attribute, because remember, velocity can be on X, on Y, and Z, etc. So in order to define this, when I attribute create something, first it's the name, then is the class. Where do I want this velocity? And I want this velocity on points, right? On the points of my grid. And the type, it's not a float, but it is a vector attribute. And immediately you see that from here, take a look again, from float, from one value, now it's a correct type attribute, and it has 3 components. So if I want to set some initial velocity of these cubes to first go down, and let me enable also this. So these cubes are falling, right, taking over by gravity, but I can initialize some velocity. So here in the, where it says value, I don't want velocity on x, but I want velocity 5 on the y-axis, going up. So what will happen now is, first, the velocity will trigger the boxes to go up with a speed of 5, and then they will be taken down by the gravity. And this is exactly what happened, right? And if I set the value of 5 here as well, the boxes will do something like this. Let's take a look. And there we go. So creating on our own the velocity attribute in Houdini, the vector attribute in Houdini, we managed to direct somehow our simulation. So this is the same thing if I go in Cinema4D and take this ugly cube that I created and add the rigid body tag. But here in the attributes manager of Cinema4D, it has this custom initial velocity. So if I make it 400 on the y initial velocity, you see the cube just jumped up. If I have this to 0, cube is taken over by the gravity. But if I set this similar to what I have in Houdini, 500 and 500, the cube will do something like this now. So as you see, I am initializing here the velocity attribute. Although in Cinema4D everything is backed, in Houdini everything is exposed to me. I have total control, and I can start playing with attributes and passing them from velocity to temperature and do crazy things. This is again a vector component, as you see, x, y, z. Velocity is also a vector component because this is the thing we started discussing, what are vector attributes. So the one and main category of attributes in Houdini is the vector attributes. I must say here, you probably ask, where do I know V and all this stuff? Well, there is a list of common attributes in Houdini that are understandable, because if I write Thanos here, I still have value of 5 in each point, but if I press play, Houdini doesn't know what to do with it, right? But when I say V, Houdini understands automatically that this is velocity. So Houdini understands some attributes by default, and you need to learn those by heart. I'm sorry. So default attributes are P, that stands for position, lowercase v, that stands for velocity, C capital, lowercase d, that stands for color diffuse, P scale. These are some of the most common ones. You will remember them. There are like 4 or 5 common attributes that you will mess around all the time. P scale, CD, etc., etc. And speaking of CD, if I go here and do an attribute randomize now, it means that, and place it here between the grid and the points, it will randomize each point with a different color, and this thing will transfer the color to this box. So let's check the structure of the attribute randomize. I don't have to create the CD attribute before I randomize it. When you use attribute randomize, it automatically initializes what I say here. So this is my color attribute. The attribute class is set to points, and it's consisted of 3 dimensions. So another a thing that kind of is weird in the beginning, here in the attribute create, you see that it says type vector, but in attribute doesn't randomize, I don't have a type. But the 3 dimensions means that this is a vector attribute. If it's 1 dimension, it's a float attribute. If it's 3, it's a vector attribute. And you can, again, if you check your info here, now you will see that I have a CD that is a 3 float attribute, a P that it's a 3 float, and a V that it's a free throw. I have all the vector attributes, and I could also add normals and whatnot. Right, so these are the vector attributes. The vectors the most complex attributes, let's say, some of the most complex, that consisted of 3 values. There are also other attributes that are consisted of 1 value, and these are called float attributes. So what is a known float attribute? Well, the most common one is the p-scale. And let's do an attribute randomize again. Place it here. But instead of randomizing the CD, I'm gonna type here p-scale. And you see here I have 3 values because by default, this attribute randomize has these 3 dimensions, and Houdini is not smart in some ways. When I should write p-scale, it should automatically do this and gives me 1 dimension because I know that float is 1 dimension. So float attributes are things that have 1 value and a decimal value, right? Remember, float in terms of mathematics is something that has decimals. So now that I defined a random p-scale for every point, here is the min and max value. And when you have 1 dimension of an attribute, a float attribute, these things here play no role, as you see. The other stuff, you can control this only with the first dimension. So this is what float attributes are, and let's take a look here. Color diffuse, vector, p, vector, this 3-dimensional thing, and p-scale, float. Again, don't confuse these float values with this float value. This describes a float attribute, while this 3 float describes a vector attribute that has float values. Sorry, a bit mouthful, but again, a 3-dimensional attribute that has decimal values, let's say, while when you see FLT without a 3 in front, it describes a float attribute. So this is an example of the most common float attribute that you will find in Houdini, right? And let's do something else. Let's create a grid again, and let's do 50 by 50, for instance. And another float attribute that has a single value that ranges from 0 to whatever is, for example, temperature. So let's go and create a temperature attribute. There are many ways to do that, but I'm going to use something that's called attribute paint. Paint attribute. So what attribute paint does is, and it has this visualizer here for us. If I select this tool, it gives me all those things, and it's a brush that it's like doing vertex weight in Cinema4D, right? So what I do here is that I initialize an attribute, a float attribute that's called mask. Let's see, yeah. Let me press the visualizer again. And there you see, in my points, I wrote this attribute that it's called mask. Very nice. Here it has many options about the brush and blah, 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 blah. But the most important settings here is the radius of your brush to paint over, add. It's the exact same as being in Cinema4D. And let's delete this thing. Create a plane, 100 by 100. Making it editable and going to, where is that? Convert, not convert vertex map, being in point mode and select set vertex weight. So now I have a value of 0. I created a vertex map, and I can use this tool right here and paint my vertex map, right? We did the exact same thing. Now we painted an attribute from, let's say that the attribute mask, this is not called mask, but the attribute mask in our case is called goes from 0, and these are the values of 1. So, sorry, let me change something here, right? So in the paint tool, I have here subtract, etc. You know, it's the same as the attribute paint. And what I'm doing here in this tag, let's call this mask, right? And I can use fields to modify this mask, expand it, and do things like that. And I can also inspect this here in the structure where it says vertex map. You see that this is a float value. So I have values that range from 0 to values that range to, yeah, you see? There we go. That values that range to other stuff. So you see, as I modify and rewrite things like this, I'm, doing the same thing that I did in Houdini. So you see a float value, a float attribute that is called mask that we can use further down the line for various operations. So for example, a simple thing in Cinema4D, let me add a displacer deformer, right? And this displacer deformer, I'm gonna use a single color, and the single color means that it pops the vertices just straight up on the Y. But if I go here to the fall off and drag this mask that I created, I'm using this mask that I'm painting to, modify my displacement. Nice. So this is exactly what Houdini does with attributes. It uses a value to map it on somewhere else. And let's do something a bit different in our case. So I have this mask attribute here, and let me go to the attributes and rename this to an attribute that I know that exists, which is called temperature, right? And when I rename this attribute, actually, I see that it you see, that's why it's useful, even if you don't see in the viewport this geometry spreadsheet. I just realized that I override my values. So let me leave this to mask and do something else. Let's do an attribute rename. The procedural nature of Houdini starts kicking in. So an attribute rename takes this mask and maps it to temperature. Great. So I created an attribute called mask, which I can use it for, it's an arbitrary attribute, it can be called anything. And I'm using it as a temperature now. So if I use a node that's called pyro source spread, to start having some fun as well, this thing, you see it created a whole bunch of attributes down here. This thing, all it's doing is it spreads the smoke, it spreads heat on our things and start catching fire and emitting smoke and all that. But let's take a look. Something is moving. And if I play a little bit with the values here, right, what we have is similar to Cinema4D, like a spread of a vertex map. And this happens because I initialized the temperature attribute, right? If I don't have any temperature, but I went and created an attribute, I renamed it to temperature, and then I'm using this temperature to do this thing right here. So what else I can do? So temperature actually is a float attribute. This is what my main point here. And float attributes, again, non-float attributes in Houdini are p-scale, are temperature, viscosity, things that have a single value that ranges from 0 to 0.1 to 1 to blah, 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 blah. So these are the main two types of attributes, vectors and float attributes. What else we can do with this temperature here, just to push it a little bit further before wrapping up the float attributes, I can take now this temperature and let's blur it. So what you can do here is I can attribute blur and say temperature. Right, so grabbing the, you see, after the fact, I have a much more blurry thing. And what I can do with this is I can use poly extrude, very silly example, let's say. In the poly extrude, I can use individual elements to distance my points. Let's inset them just a tiny bit as well. In the poly extrude, I can go where it says local control and enable the z-scale. I think we saw this in the previous example. And if I name the z-scale to temperature, what it's doing is temperature, right? Temperature. Right, it's not working right now, but what I'm trying to do is to pass this temperature on the z-scale. And why this isn't working, this is a good example actually. So as I said, attributes flow in various aspects of our geometry. And in this case, the temperature is a point attribute, okay? And therefore, while it exists here in my points, the polyextrude, when I enable these distance scales, if I hover on it, it says multiply this extrusion, blah, 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 primitive attribute. So makes sense because it's an extrude and we extrude primitives most of the time. So what I can do here is I can use promote, an attribute promote, and procedurally take the temperature attribute again, and from points set this to primitives. And there it got transferred here, right? And this is points, vertices, primitives. And now, you see that we're carrying this hot temperature on our points, and obviously this is too much. So we can just go and clamp it and remap it and do all sorts of things right here. Or simply in my case, let me do a smaller distance, right? Right. By the way, you see this visualization because by default, Houdini, when you add this pyrosaur spread or this mask, it enables this icon here, which is, these are the visualizers. And this is also something very helpful because this visualizer, if you enable it and right click, you can see that I'm seeing the mask or the temperature and whatever attributes that I already have. Very, very useful tool right here. Let's leave it actually. Let's actually disable it, right? And as you see, I passed a single attribute that I created by converting it and changing it a few times to a polyextrude. And of course, if I add the color node on top of it, I can keep using this, if I say ramp from attribute and be on the proper class on primitives, I can check the temperature, right? And you see, I can create, it has some presets here in the gradient which suck, but what is this? Yeah. So you see that I can simply just play with my colors here after the fact, after I do all my operations and stuff and change the range of how sharp or how this how smooth or how sharp my color will be. But again, all this happened with a single attribute. And I connected this single float value in all aspects of my geometry and in nodes and so on and so forth. So vectors and float attributes are the most common attributes we will find in Houdini, and we will always play with changing classes from points to primitives. We will always play for creating an attribute, passing it somewhere else, multiplying it with another attribute. I mean, the possibility now the rabbit hole starts and the possibilities are endless, but I hope I gave you a better explanation of what attributes are in more depth. Again, the vector attributes have 3 dimensions, x, y, and z, u, v, w, RGB. These are called vectors. The float attributes have a single value that ranges from 0 to whatever with decimal numbers. And there is another kind of attributes. Let me show you another example really quick, which are integers. And integers refer to numbers that are, let me duplicate this sphere and push it here, duplicate it one more time and push it here and merge this. by selecting all objects, holding Alt and dragging your mouse, it creates a merge. And there is another type of attribute. Let me do less rows and columns, right? There is another type of attribute that is an integer attribute. And integers are like whole numbers, right? An example of this integer attribute is if I use a connectivity node here, right? The connectivity, it creates on points an attribute that is called class. So let's check our points. So class 0, connectivity understands a whole geometry and assigns this class attribute on the whole geometry. This can be called anything. This can be called whole piece, for instance, and still corresponds to a closed geometry. And let's add some color here, right? And change the group type to points, because I know this connectivity is referring to points. And let's create a color, right? And let's type a little expression to access the attribute that I just created, this integer attribute. So I can say at. When I use at, it means that I'm accessing an attribute, and this attribute is called whole piece equals 1 equals 0. Did I spell it correct? Right. So it doesn't need the spaces there. It doesn't seem to work. So I said that whole piece equals 0, make it blue, right? So if I say this to 1, now I colorize the other sphere. And again, this happens procedurally. So by enabling this attribute class, which is an integer attribute, an integer means a whole number, because I can't have a 0.5, it doesn't correspond to something in the sphere. So integers are whole numbers, and this is an example of an integer attribute. One last attribute that exists in Houdini, it's those details right here, which I'm not gonna go over, because details are more abstract things. But keep in mind that the most common attributes we will use on points and primitives, we will use vector attributes, float attributes, and some integer attributes down the line. This was a bit tough to explain, and I'm not sure again if I explained it thoroughly or in depth or with good examples from Cinema4D. But let me know if you need further explanations down the line. Try to look also for vectors versus float to see the difference. Again, you see that this is a vector attribute. This is an integer attribute because it has whole numbers, and this is a vector with float values. I don't have a float attribute here, but let's do an attribute create to have all and compare them. Let's place it also here. And yeah, now I have this attribute 1. Let's call this Thanos and use a value of 0 point something. Right? So again, vector attribute, single value with decimals, therefore is float, single value with whole numbers, therefore an integer attribute. So you see here in the description, 3 vector float, Thanos a float, and the whole piece that it's integer. So if you understand all this and how attributes work and how they remap and they rename and they expand, because as you see, I can connect anything to anything, I can rename anything to anything, and as long as name matches and classes matches, you can do so many things. So thank you. I hope I won't do a lot of boring stuff further down the line, and I will just go to the fun stuff. But bear in mind, you need to see all of these tutorials I did so far in my channel to have at least a basic understanding of how Houdini works and how navigation works and all of this, because at first this is too much, like it was too much for me. I've spent a lot of hours to try understand some very basic concepts, and I think I am by no means qualified to do tutorials about Houdini, but I'm gonna try to do this from an art director and a Cinema4D guy's perspective. So stay safe and see you very soon. Ciao.